Okay, gang. Section 9.1, Section 9, we're into Chapter 9, solutions and their reactions. So we're going to use something that we've done before and add a little bit to it. And hopefully this is pretty straightforward. This first section is reactions of ions in solutions. So we're going to deal with ionic compounds in this particular section. So recall earlier that we learned what a dissociation equation was, where we took an ionic compound and we added it to water. So we had a solid, added it to water, and we broke it into two individual ions, and their subscripts became AQ. So for example, NaCl, solid, dissociates into Na plus AQ plus Cl negative AQ. So into their individual ions, and they're both AQ because they're now aqueous solution. So here's one of those here at the top, right? If we take BaSO4, which I know if I quizzed you, you would all know is barium sulfate. Solid, dissociation. Ba plus 2, because there's only one of them, so you get one of these ions, AQ, and SO4, the sulfate, also AQ. Okay, so that's dissociation. What we're going to look at today is adding to that is we're going to take chemical reaction. Sorry, I didn't write it very straight. Okay, so BaCl2, barium chloride, plus Na2SO4, sodium sulfate. Both are aqueous solutions, so those would both be clear liquids. When we mix them together, we get a precipitate, which we've talked about as well. BaSO4, barium sulfate, which is solid, and two NaCls. Okay, now the way we can tell where these go, if they don't tell you what the subscripts are, remember we have that solubility chart, and we just go find them. So for example, if they say these two solutions, what do you get? Well, we have to realize, and here's a good final test like question, is that realize a double displacement reaction. So we're going to change partners. Ba now is going to join with SO4. So we'd go to our solubility chart, and in this case on page 424, and I'd say, okay, sulfate. Look for the sulfate ion in there, and I've got barium sulfate. So if you look at what we've got there, that's an exception. Sulfate, SO4 negative 2. They are soluble except with Ca, Ba, Sr, Hg, Pb2, and Ag. Ba plus 2 is one of them. That's why this becomes a solid. Over here, and obviously NaCl, basically any of our NAs, there are none. Anything that joins with sodium is going to be soluble, so it's AQ. Okay, so what we're going to do is we're going to come up with now what we call the total ionic equation, which means we're just going to dissociate everything. Okay, so let's do that. So the first thing we're going to get is the BaCl2. So we're going to get Ba plus 2 AQ plus 2 Cl negative AQ. Okay, two of them because you have two chlorides in this particular one. So we've got two there, so 2 Cl negatives. Plus, let's associate the other partner, 2 Na positive AQ plus SO4 negative 2 AQ. Okay, that's my son freaking out playing Fortnite and wrecking my videos because he can't keep his mouth shut. Two of them, because there's my two again, so I got two sodiums, just one sulfate. Okay, so what do we get from there? Over here, BaSO4 stays all together because it is a solid. It does not dissociate. So anything that's a solid doesn't dissociate, stays where it is. So I come over to this piece. Coefficient of 2, same thing as a subscript of 2 for numbers, 2 Na plus AQ plus 2 Cl negative AQ. So there's my total ionic equation. Okay, so I want to then go to what I call my net ionic equation. And the net ionic equation just basically means anything that is exactly the same on the reactant side as it is on the product side can cancel out because it's net. So if you have, it's just like in math, if you have an equation and then you have, if you had 2 to one side and 2 to the other side, you really didn't do anything. So let's see what we've got. Do we have a Ba plus 2 on this side? No. Do we have 2 Cl negatives? Yes. So we're going to cancel there and there. 2 Na plus. Yeah, I got it right there. SO4 negative 2 I don't have. Okay, so let's write what's left. Ba plus 2 AQ plus SO4 negative 2 AQ makes Ba SO4 solid. Okay, there's our net ionic equation, and that's what we're looking for. Yeah, so the other thing, the only other term we got to have, and I'll put it in here, these ones that we're crossing out, they call these, all these ones that are being crossed out, these are called spectator ions. So how many sets of spectator ions do you have? Well, you have two. You have the 2 sodiums and you have the 2 chlorides. Those are your spectator ions. Okay? So all 9.1 is balanced chemical equation. Dissociate all parts that are aqueous in that particular equation, and you'll have to use the solubility chart to figure out if it's aqueous or if it's not. And then cross out all the matching spectator ions on each side. Remember, they got to be on each side of the equation arrow. And then write your net ionic equation at the end. Okay, that's all there is to it. Hopefully that one's pretty simple and you get through it pretty easily. And then later in the week, we'll go in and finish most of chapter 9. There's only a couple more sections. They're also pretty straightforward. So we'll get into those. And then chapter 10 really is our last one together. And we'll try and get through that by next week. Okay, good luck with those. Again, send any questions. Hope I've been getting some. Hopefully a lot of you have been doing it as a group and sending in group questions, and that's great. I'll keep answering them, and hopefully you'll be as prepared for the grade 12 next year as possible. Okay, good luck with those.